Hello, 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 and welcome back to another episode of Kerbal Space Programming. Kevin here, and today I want to talk about a subject that came up on the KOS subreddit regarding when. Now, when, of course, is something that we've really not talked about in this series because I've made a deliberate decision to kind of avoid using it. But let me show you some examples. These are when is a keyword that has existed in the language for a very long time, and I've avoided it for specific reasons. But let me show you kind of how it works. So I have this sort of dummy script here where we say, okay, we're launching, we're going to lock our steering, we're going to lock our throttle, and we're going to stage a craft. And now we're going to say when the altitude is greater than 30 kilometers, then do a thing. Lock our steering to 90-65. So start a gravity turn at that point, whatever the case may be. Then we have another one where we say when altitude is greater than 70,000, then turn on the solar panels and throttle off. Now, of course, this isn't based on any real craft or anything that we're flying. This is just sort of a demonstration of how the syntax works. Now I have another example down here. It says when the ship's electric charge is less than 10, then call some function called disable antennas, and then there's this other keyword called preserve. So what's going on here? Well, it's fairly intuitive from an understanding English perspective. We simply say when this thing is true, then do whatever is inside this block. That makes sense. The only thing that kind of throws a wrench into things is this preserve here. So what actually happens behind the scenes is when we look at a when body, what happens is when we call this, it says, all right, I'm going to take this bit of code and I'm going to put it into a special place that runs at the beginning of every physics loop. So it tries to run it as often as it can, and as soon as it's true, it'll go ahead and run the associated block. And that means it'll run, turning on the panels and lock the throttle and etc. And as soon as it's true, it'll go, all right, it's finally true. I'm no longer going to check it. I'm going to discard it. And that's great. Now, when we have something called preserve, now we're checking all the time whether or not the ship's electric charge is less than 10. So we want to make sure that we don't run out of power because we've got crazy antennas, using all of the electric charge. Well, we've got this here and we say preserve. That means that even once this thing passes, continue to check every single time, because we don't want to, enable our antennas later and then go, oh, now we managed to drain our batteries. So preserve is a way to make sure that we do this over and over and over again, and this interrupts stuff. Now, there are a couple of reasons why I'm not a fan of this approach. One is that it's a little bit difficult to figure out exactly where your code is going to run, because these don't block. What we've done occasionally is say, wait until altitude is less than 70,000. And if you have some code after here, then this is never going to run until you've reached that 70,000. When you use a when, it doesn't block. It puts the code into a special spot that says that, okay, the KOS CPU is going to check that as often as it can, and it's going to run the regular program sort of in the meantime. So this becomes sort of an interrupt. So as soon as this becomes true, it's going to stop whatever it's doing. It's going to, okay, I'm going to do this now. So that can make it a little bit difficult if you're trying to figure out exactly when your code is going to run. It's a little bit more difficult to reason about. There are a couple of other restrictions. One is that the stuff inside this block doesn't run in the context where it's declared. Let me explain what I mean by that. If we have something like a function foo, and I have a variable bar is 5, and I have something like here, it says print bar. Now this isn't actually going to work. It's going to say, I don't know what bar is, because bar only exists inside this foo function. Because of the way that this is pulled out, because it's kind of this global, I'm going to run this all the time, it ends up actually extracting this and running it outside in its own context, outside here. And so if bar isn't declared outside at the absolute global scope, then it's going to run into issues. There's a couple of other performance concerns, particularly with this preserve. If we have a lot of these, they end up counting against the number of commands that we're able to run every physics tick. And in particular, these will, like this one will never end, right? There's no condition under which to stop it. Now we could change this by saying or done. So we'll have now two conditions under which this thing would fire. And we'll say if not done, then do this. So then there are two ways that this thing can end up firing. So if we run low on electric charge, it'll say, all right, done isn't true, but we'll disable the antennas and preserve. But then we could also say set done to true later. And then it'll go through in a fire and say, oh, you know what? Yeah, we've run this, but we didn't get a preserve that time, so we're not going to go ahead and continue to check this from here on out. So there's some workarounds, but it's kind of understandable why people are a fan of this style, because a lot of times you don't know exactly when things are going to happen. Like if you're trying to make sure that you don't run out of electric charge, you're not saying, let's check about our electric charge at this altitude and between these particular steps of the mission that we're trying to run. You want to just do that all the time. You're saying, meanwhile, we're going to do our mission, but also please be sure to be checking on this electric charge and that sort of thing. So this is one of the reasons that this style sort of appeals to people, but it does end up with people getting very confused. And so I want to talk about some of the alternatives that have been proposed for writing code like this. So I should mention that this comes out of a lot of discussions over on the KOS subreddits. This is not all just kind of me coming up with crazy ideas. One of the strategies that's been applied with a lot more success, and this is actually based off of the original Apollo programs, I believe, is to use run modes. Now, what are run modes? Run modes are basically the whole idea here is that we have one very big loop. This goes down, all the way to the bottom of the file. And what we're going to do is we're going to say we've got a whole bunch of if conditions. We're going to say if the run mode is 1, then we're going to do some stuff. Otherwise, if the run mode is 2, we're going to do some other stuff. Otherwise, if the run mode is 3, we're going to do some more stuff, etc., etc. So let's think about how this actually works. We'll say until 0, so this loop will just run forever. You can make it end if you wanted to, but we're not going to worry about that. So we start off with a run mode of 1. We say, okay, if the run mode is 1, we print that we're launching, do that staging stuff, and then we're going to set the run mode to 2. All right, so that sort of makes sense. Then we say, okay, else if, but we don't go to the else if because we already ran the if. That means we don't look at the other opportunities. So we go down this loop, and we go, okay, so these were the else ifs. Now here we have this if. We say if the ship electric charge is less than 10, we'll disable the antennas. Okay, that's fine. So we do that. Now we've gone through and we'll wait a little bit so we don't thrash the CPU. Then we go back to the top of the loop again. Now this time our run mode has been updated to 2 because when we were in here, it updated it. So this if does not pass. We go to else if run mode equals 2. Now inside here we say, okay, is the altitude greater than 30,000? Well, probably not. Probably not if we only just launched. So nothing ends up happening in here. And we don't end up getting into these else conditions. But we do go through and check this electric charge again. And we go through this loop over and over and over again, making sure that we reevaluate this electric charge all the time, even while this is waiting. This is not the same as, wait until altitude is greater than 30,000. Now this is just going to go ahead and sit around and be completely patient, and we could put any number of other things here. We could have, print reports or whatever we wanted to do that's going to happen every single time this thing is looping. We don't have to worry about, these things are running sort of almost concurrently. They're easily just saying, I'm not doing anything right now. You go ahead and monitor the electric charge. Then finally, we go ahead, we set run mode to 3 because we've hit that altitude. So we do our gravity turn, we set the run mode to 3. And now run mode 3 is doing the same thing. It's just waiting. So it's going to do nothing over and over and over again while the electric charge is being managed. And then once it's done, it's going to set the run mode to 0 because it's done its stuff and it's saying, yeah, don't call me again, I'm good. So there we go. This is another strategy. Now, there are a couple of things that, I don't know, personally, I'm not a huge fan of. We could probably clean this up and make it a little more readable. And it's kind of understandable why people don't pick up on this right away, just because it looks a little ugly. You've got these, you've got this very long nested chain of else ifs, which generally is not considered the best of practices. It's a little bit hard to declare. Now you've got these conditions where these run modes are attached to, like, the launch. The bit of code that's worried about launching has to know about these run modes and what they're representing. But you do have some significant benefits. For one, you don't run into that whole, we don't have access to the variables in the right place. You don't run into the issues of this thing is going to interrupt at some random point in time. And you do have the ability to still say wait until something. If you really need to say, no, we can't wait and check the electric charge. We need to hold and pause for something. You can't interrupt here. But probably the biggest benefit is that we have this run mode variable. And what this run mode variable represents now is where our program is at. And that means that if our CPU reboots, or we switch away from the craft and come back to it, well, all we really have to recover is that run mode. We don't need to worry that, oh no, if we restart, it's going to go ahead and say, hey, I think I'm on the launch pad. Why don't I do some of that? Why don't I stage? Which can be a nightmare if you write your program sequentially and you've got, stages at the beginning, then all of a sudden you switch away and you come back and it's like, oh no, we just deployed our parachutes for no reason. That's wonderful. Now we know, okay, well, if we just save out this run mode somewhere, we could save it to the core part tag, or we could save it out to a file, well, then we can actually recover stuff. So I'm going to go ahead and try and polish this file up a little bit and make it a little easier to work with. Alrighty, so I've cleaned this up. Now we've got some nice names, and this is, again, a lot of tips that are coming from the KOS subreddit. We've got, instead of run modes, which were numbers, I'm going to actually say set the launch to 1. I'm going to set gravity turn to 2, and I'm going to set main engine cutoff to 3. I'm going to give these helpful names so that when we're looking at the actual run mode loop, it sort of makes sense. Next I've got here, I'm going to say, okay, set the run mode to 0, and I'm going to create a function called set run mode, which sounds pretty intuitive. I'm going to take a parameter, takes a parameter mode, and we're going to write JSON a list with that mode. So it's just a list of one element because we can't write out the mode by itself. We're going to write it out to a file called runmode.json on our archive, or on our local volume. And then we're going to set the run mode to that. So all we're doing is we're saving that stuff out to a file. It's kind of a cleaner way of doing the log, such and such to a file. So now rather than saying set run mode inside, set run mode to 2 or whatever inside our actual loop, we'll actually call this function, and that way it can both update the internal variable, but also write out the new value to a file so that if this thing does reboot, it's able to recover. And we see down here that's exactly what it does. We say, okay, if the core volume file has a key called runmode.json, so if this file exists, then set the run mode to whatever we read out of that file. Otherwise, set the run mode to launch. So now we have this event loop again. We can see I've split this up so that it looks a little bit nicer. We've got if the run mode equals launch, then we've got the stuff, and it all looks very much the same. We've just got set run mode as a function instead of set space run mode. And there we go. We just do kind of the exact same stuff. We've got this all coming down here. Now, this is better, but I'm still not a huge fan. There's one thing that kind of irks me, and that is that if we look at these actual steps, we have these constant names to refer to the run modes. So we have these names that refer to these blocks of code. And then we have these blocks of code whose job it is to manage one specific task. So we have named blocks of code that are supposed to do small things. That sounds suspiciously to me like a function. And so I decided that I would like to try and take this approach a little bit further and take away some of the run mode-y stuff and try and hide that, to sort of abstract that out so that we can write stuff using functions and have the actual run mode logic kind of handled behind the scenes. The other thing that I want to point out is just this if and else if stuff. It ends up being a bunch of noise, and it also means that, for example, these three, when they're doing their set run modes, should the launch know about the gravity turn? Or should the gravity turn know that the main engine cutoff is the next thing? I don't think that that's the gravity turn's job. I think the gravity turn's job is to say, lock the steering to heading, and then say, I'm done. That's all that I'm going to do. You worry about whatever happens next. Now, one last thing that I should mention, though, is that there is one benefit, and that is that in these particular examples, really what we are saying is just done. But there could be examples where maybe a run mode says, we landed on another planet, so you need to go back to the launch run mode now, right? These don't necessarily go in a particular order. There may be cases where we want to backtrack or we want to branch off to different steps. So having this set run mode doesn't make sense for me in this particular case, but it doesn't necessarily mean that it's always a bad thing. So whatever solution we come up with does theoretically need to be able to support something like this in the future. So this is the approach that I took, and you'll see that we've got kind of, these lines are kind of the bulk of handling the actual sequence. So I've got something called set main sequence to a list, and you'll notice that it looks an awful lot like a lexicon. It's just these key value pairs. And the reason that we're representing it as a list instead is just because the order of these steps actually matters. And although the lexicon does maintain order of the keys and values, we don't want to necessarily rely on that because it could change in the future. So we've got this main sequence, which is a list, and it's a nice name, launch, and then the function delegate name. We've got gravity turn, and we've got a gravity turn delegate, and we've got main engine cutoff, and we've got a main engine cutoff. So that's great. Now we've got now we've got something that is a lexicon. In this case, these are the events, the things that we want to happen as frequently as possible in our event loop. And we've got one that's the power check. We've got a function called ensure power that's going to do that. Now these, we don't want them to be a list because it's possible. If we imagine that, say, after launch, we want to have something that auto stages, that may be an event that we want to run all the time, but only between certain steps. So we may say that inside our launch step, we say, add this event, please. And then once we've done our gravity turn, we'll say, remove that event. So we want to make sure that even though that we don't try and accidentally manipulate this list of events by number, that we want to say, okay, maybe I want to add something to this event, but I want to refer to it by name and not by number. So we've got these two things. We've got the main sequence, which is just the steps of our mission, and then we've got events, which are just named things that should happen as often as possible. And then we have this thing called run mission, and it takes the main sequence, and it takes the events, and that's it. Well, not entirely. So let's look real quick at these functions. So these functions are pretty much just exactly those little code snippets that I just pulled out. The only difference is that now they take a parameter called the mission, and this mission has a function called next. So all we're doing is we're saying, when I'm done, I'm going to go ahead and call next. Now I could also do something, I could say switch to, and I could give it the name of something. So I could say switch to main engine cutoff. But in this case, I don't care about what happens next. All I know is I did my launch, I did a good job, I'm done. And so I'm telling the mission that I'm done, and I'm telling it, whatever run mode stuff that you're doing in the background that I never have to worry about again, you go ahead and do that right now. And the same is true with the gravity turn. It takes a mission, and then it only says next once the altitude is greater than 30,000. Otherwise, it doesn't call that, and so the mission knows that, all right, we've got to go ahead and call this step again the next time we come around in the loop. And the same thing with the main engine cutoff. And then finally, we've got the ensure power function that just says, all right, if the ship electric charge is less than 10, disable the antennas. Of course, we should probably write that function if we were actually going to launch this, but this also takes the mission because there are a couple of additional things on the mission keyword that we could go ahead and call. So I could say mission add event, and I could give it a name, cool thing, and a function delegate, cool thing. I'd have to actually write that. But this would go ahead and add it to the loop. So every time it's going through its event loop, it'll go ahead and try and run that. And then later I could go ahead and say mission remove event, cool thing. Or I could even say if all goals achieved, whatever that would mean, I could say mission terminate. And then the event loop itself would go ahead and stop. So there are a bunch of just sort of helper functions that are available through this parameter, but we don't have to worry about the details of actually scheduling these tasks, because that's really not what our mission should be about. The details of getting into orbit should be completely decoupled from how are we ordering these tasks and how are we handling the transitions between all of these various steps and blah, 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 blah. Instead, all we have is the main sequence of tasks that we want to do. Usually they're going to go in order, but if we want to manually say, nope, switch to launch again, we can go ahead and do that. And then we've got the events that are just run this as often as possible, because this is sort of a background job that should run very frequently. So let's take a quick look at how this mission runner is scripted. Alrighty, so I've got way too much documentation here, because I was just trying to make sure this was helpful. You can see, yeah, here are the examples of, we've got add event, which takes a name and a delegate, remove event, next, switch to run mode, which will just tell you the current run mode. If maybe you're in an event and you want to know, what are we currently doing? Then you can figure it out that way, and terminate, which will end the event loop. And we've got kind of examples here of how this might happen. Okay, so how does this actually work? Well, we're using delegates and lexicons and all of that fun stuff. So we have this mission runner, which is what run mission actually is. And we'll say we take a parameter, sequence, and events. And if you didn't pass any events, we'll create an empty lexicon of events. We'll say the run mode is 0, and we'll say done is 0. And we're going to create that mission object. And this mission object is just a bunch of keys and delegates. So we'll jump down and see what those are. We've handled that same that same recovering of the run mode. There's a little bit of trickiness involved here because the sequence is a list. So there are cases where we're doing this whole run mode divided by 2 sort of thing, because what we're actually saving out isn't the number. We're saving out the nice name, which we call launch or main engine cutoff or whatever. And then here's the actual main event loop. It is nice and short. It's saying until we're done, we're going to take the sequence and we're going to say whatever the current run mode is and times 2 plus 1, which is the frustrating thing about having both the names and the functions in that list. But we've got that, and then we're going to go ahead and run it, but we're going to pass in that mission object. And then we're going to say for every event in our lexicon, we'll go ahead and call that and pass in the mission, and then we're going to wait 0.01 seconds. And then once if we're given reason to terminate, then we'll go ahead and delete this mission run mode file, which we're saving out to go ahead and recover. So this will actually go ahead, and if you stop the thing or you switch away or you come back to it, it's entirely fine. You boot it up again and it will figure out where the run mode's supposed to be at, and it'll go ahead and do that. So there's a function here that does the same thing. It writes out the nice name to mission.runMode on the craft. There's a helper function that gets the index of that name in the list. And then we have all of these mission functions and kind of how those are defined. So add event just takes that events list and adds a name to that list or to that lexicon. We've got remove event, which does the same thing. We've got next, which just updates the run mode to run mode plus 1. We've got switch to, which updates the run mode to whatever the nice name is. So it takes that nice name and it gets the actual run mode number that should be there. We've got something that'll give us the actual run mode, and we've got terminate, which sets done to true. So this code is a bit of a bit long. Most of it is comments, to be fair. It's less than 100 lines. But the whole idea here is that now if we're looking at, I had another example actually that I was using. Come on. Just to test this so I didn't have to launch stuff. But the idea is that we can now have this very simple way of talking about our mission, just kind of within these 2 comments, that this describes the entire process of whatever it is that we want to do. Die eventually, that's meaning the program. That's not meant to seem quite as morbid. But the idea is that we can actually just describe our mission, and that the job of these functions, the job of these portions, these snippets of code, can be completely agnostic to the fact that it's being run as part of a mission. We can say, let's design a function really well that wakes up or smells the roses or is awesome, or more likely circularizes or transfers to another sphere of influence or whatever the case may be. So all of this is really to say that it's very understandable why the when-then pattern of developing code seems to have some sort of appeal, because there are tasks that aren't necessarily in sequence. You want to be able to run multiple things at around the same time. But we do have the flexibility to structure our code in a way that makes that possible without a lot of the bugs and trickiness that comes along with it. And if we're willing to spend some time messing around with some libraries, then we can go ahead and make that a very intuitive process as well. So if you're interested in using the run mode code that I ended up writing, that'll be the top link in the description. Otherwise, we will go ahead and use this for Project Athena in the next episode. So I will hope to see you then. Cheers.